So let us look at the current voltage characteristics of BJT, bipolar junction transistor. First of all, the characteristics is a curve between voltage and current. How current changes with respect to change in voltage, or vice versa it can be. In case of a transistor BJT, since it has three terminals, okay, you have base, emitter, and collector. Now it is possible to have two voltages. Maybe I can say VBE is one and IB is a corresponding current, which we call it as input voltage and input current. And likewise, VCE is the output voltage, and IC is the output current. So this particular configuration, we call it as common emitter configuration. So in a common emitter configuration, I will draw the graph between IC versus VCE at a constant IB or VB. This gives me how output current changes with the output voltage, and this is called output characteristics of transistor in common emitter configuration, and it would be something like this. If you see, initially it increases, and after some collector to emitter voltage, it is becoming constant, and this constant current region is being referred to as active region. The reason, the constant current with respect to output voltage, but it is dependent on the input current, meaning if I have another IB, I change IB, the constant IC will change. Let's say this is IB1, this is for IB2. So output current is a function. In fact, it is beta times IB, and this region is called active region with VCE, and this is called, in fact, saturation region, where current is increasing with respect to voltage at a fixed input current or input voltage, fixed IB or VBE. This is a function of the resistance. So this is called saturation region, where it acts as a resistance. Okay, and there is another region where IC is completely zero. This is the case where VBE is less than 0.7, where even IB is zero. So there is a minimum, it's 0.7 volts. There is a minimum voltage for the transistor to conduct base current. That voltage is 0.7 volts for silicon NPN transistor. Now from here we'll see how the input characteristics look like. The input characteristics are more likely to be a forward diode characteristics. The reason, if I take an NPN transistor, let's say this is the collector, and this is base, and this is emitter. Okay, so here this is P and this is N. This is if I carefully notice, okay, there is a voltage source from base to emitter, let us say, and there is current flowing through the base to emitter junction, and this is exactly as forward bias diode. So the characteristics, it is not surprising that the characteristics are same as forward characteristics of a diode, where this is IB and this is VBE. Of course, here we make sure that VCE is kept constant at constant VCE. As you change VCE, the characteristics would also shift. Let's say this is VCE1 and this is VCE2. Okay, meaning there is a minimum voltage that is 0.7 volts for silicon NPN transistor for the conduction of base current. Once it started, the current rises drastically as if the current of a diode. So you can mark that the region where VB is less than 0.7 is your cutoff region. Cutoff region, meaning the transistor simply doesn't conduct any current. So it can be treated as an off switch. So what are the three regions? First is the region where IC is merely function of IB and does not depend on VCE, and this region is active region. What is the application? Application is amplifier. Second, where IC increases with VCE, with an increase in VCE, this region is called saturation region. Saturation region, where the transistor acts as on switch with some resistance. It's as if you have a resistance and in series with there is a switch which is on, like this. What is this? This is from, let's say, collector to emitter. This is how it acts, it functions. And thirdly, the case where you have VBE less than 0.7, meaning IB is 0, even IC is 0. This is cutoff region, and transistor acts as off switch, right? So total, how many regions? There are 3 regions. And how do you identify these regions? From the characteristics. If you see this, because you're drawing a graph, plotting a graph is showing how IB changes with VBE. This is input current and this is input voltage, because we are dealing with common emitter configuration. Common emitter configuration, emitter is same, emitter is common terminal for both input and output. And the previous one, where we have drawn the graph between collector current, how collector current changes with VCE. This is called output characteristics. Characteristics plot. Okay, so there are 2 graphs which are needed. to understand the operation of a transistor, and you can, okay, decide upon which region of operation it is operating. If the current is constant with respect to VCE, then it is active. If it is increasing with respect to VCE, it is saturation. And if there is no current at all, it is cut off. And if it is active region, it's an amplifier. If it is saturation region, it's a non-switch with resistance. If there is no current, it is off switch.